non-exact differential equations. So before we start, shout out muna kay Rowell Evangelista of BS ECE and to all of my students, BS Computer Engineering and BS in Ceramic Engineering. Okay, so let's go non-exact differential equations. In the differential equation represented by mxy dx plus nxy dy is equal to 0, if the partial of n with respect to y is not equal to the partial of n with respect to x, the equation is said to be non-exact. So it is, however, possible for some few special cases that the multiplication of each term by a function phi xy will reduce it to an exact differential equation, or m phi dx plus n phi dy is equal to 0, such that the partial of m phi with respect to y is equal to partial n phi with respect to x, wherein phi xy is called the integrating factor. So determination of the integrating factors, we have three cases. So first case is wherein the integrating factor is a function of x alone. So if the integrating factor is a function of x alone, we use the f of x is equal to 1 over n times the quantity of partial of n with respect to y minus partial of n with respect to x. And the integrating factor is equal to the e raised to the integral of f of x dx. So case number 2, the integrating factor is a function of y alone. So if the integrating factor is a function of y alone, we use g of y is equal to 1 over n quantity partial of n with respect to x minus partial of n with respect to y. So the integrating factor is equal to e raised to the integral of g of y dy. And last case, case number 3, the integrating factor is equal to x raised to n, y raised to n. So we use the n minus y minus n over x, n over y minus n over x is equal to partial of n over partial of x minus partial of n over partial of y. So we use the integrating factor of x raised to n, y raised to n. Note that m and n, the small n and n are constant values. So we also have integrating factors determined by inspection. So we have 7. First is the derivative of xy is equal to x dy plus y dx. Second, derivative of x over y is equal to minus x dy minus y dx over y squared. Third is the derivative of y over x, x dy minus y dx over x squared. Fourth, the derivative of inverse tan of y over x is equal to x dy minus y dx over x squared plus y squared. Fifth is the derivative of 1/2 ln x plus y over x minus y is equal to x dy minus y dx over x squared minus y squared. Sixth is the derivative of y squared over x is equal to 2xy dy minus y squared dx over x squared. And last, the derivative of x squared over y is equal to 2xy dy minus x squared dx over y squared.